So today we're doing the volume of a pyramid. So we have already done the volume of a prism, and that is V equals AH. Now a pyramid is something that, well, you've seen them in Egypt or pictures of Egypt. They go to a point, all right? So a pyramid has a base shape which gets smaller and smaller in cross sections until you end up with the point. So if you think of the pyramids in Egypt, they are square pyramids. So they have a big square base, a really big square base. All right, now if we slice the pyramid through like that, you'll find that that big square base still is a square wherever you cut it, but the higher you go, the smaller the square is that you've got as your cross section. And eventually you end up at a point right at the top. Okay, so if we have a look at what happens with a pyramid, so if we have two things with the exact same base shape, and one's a pyramid and one's a prism. If we fill the pyramid with water and pour it into the prism, how many do you think of the pyramids will fit into the prism? Well, the answer is always 3. Okay, so the volume of a pyramid is exactly 1/3 of the volume of a prism. So the volume of a pyramid formula is 1/3 of what we had for the volume of a prism, which is AH. So it's 1/3 AH. The A still stands for the area of the base shape. The H still stands for the perpendicular height of the pyramid this time, which comes off or away from the base shape. Okay, now when you are drawing a pyramid, the easiest way to do it, it's not the only way, but the easiest way for you to cope with working, is to draw the base shape. Now, I've drawn a rectangular base shape there. You can't tell it's a rectangle at the moment, but once I put right angles in, it's a rectangle. It's been drawn with depth, so that's why they're all on an angle. Now, if you look at the middle point of that shape, mark it. If you go directly above it and mark a dot up there, it's easiest to do it that way, because then once you've got that point, you just join that to these points here. And that one at the back there, we really can't see, so we put a dotted line in there. All right, and that's how you draw it. Okay, volume of a cone. A cone, remember, is still got a circular base. It's still going to a point. There it is. So it's really a circular pyramid because it's got a circular base. But instead of calling it a circular pyramid, we call it a cone. It still has the volume formula 1/3 AH. But in place of A, because it's got a circular base, we put pi r squared in for the area. Okay, so if you can't remember that formula, I'm not writing learn next to it. This is the one you need to learn, and then you can develop that from it. Okay, so R is your radius, H again is your perpendicular height of your pyramid coming away from your base shape. Okay, so we're going to go through some examples here now. Now, the first 2 are just finding the volume. Okay, so if we look at this first one, I'll draw the rest of this now. I've shown you how to draw it. Okay, so I'm drawing the rest of this diagram now. Now, that red line joins from the point at the top of the pyramid to the middle of the base. So draw it in another colour, it's just easier for us to see what's going on. Okay, so they're all the measurements they've given us, so we're going to go from here. So we're starting with V equals 1/3 AH because we can see it's a pyramid, it goes to a point. Now, the A is the area of the base shape. If we look at our base shape, it's telling us that all the 4 sides are equal and there are right angles there, so that is a square. All right, so we're putting the area of the square formula in for A. S squared goes in that spot. And now we're going to sub in our numbers. So it's 1/3 times, the side length of the square is 8, so it's 8 squared, times, now the perpendicular height coming away from your base shape. Now, they sometimes will just draw it in like that, which they have here. That's your perpendicular height, and sometimes I'll actually show you that it is perpendicular by drawing in a little right angle, something like that. Okay, so that is our perpendicular height. Now you go to your calculator and you put all of that in, and it's going to give you an improper fraction when you get your first answer. So you're going to use SD or Shift SD to change that answer. I'm writing it as 149 1/3. I've changed it to a mixed numeral. If you're going to give your answer as a decimal, you give it as 149.3 recurring. Okay, don't try and write that any other way. It has to be exact. So I prefer to go to the mixed numeral because then I don't have to worry about any recurring decimals. It's centimetres and it's volume, so it's cubed. Okay, in the next one, we start with our same formula, V equals 1/3 AH. We can see it's a pyramid going to a point. Now, the base shape here is on the bottom and it's a triangle. So you can see it down the bottom here. Okay, so we're going to put the area of our triangle formula in for A. So half BH goes in there. Now we're going to sub straight into this. Now remember the B and the H are to do with the triangular base. So let's start down there. Its base is 18 and the perpendicular height coming off the base at right angles is the 14. So it's 18 and 14 going in for that. And then we're looking at the height of the pyramid coming away from the triangular base. So this is the red line I've got in there. And that's 8. So that is the height of your pyramid. So if you put all of that in your calculator, you'll get 336, and it's in metres cubed for volume. Okay, now the next question is building on the level of difficulty now. So they've asked for the perpendicular height, the volume, and the capacity. So let's see what they've given us. So in this diagram, we have a pyramid because it goes to a point. The base shape down the bottom here, we've got a couple of right angles in there, so it's either a rectangle or a square, but they're both 20 centimetres, so it is a square. Side lengths are the same, so it's a square down the bottom there. Now the first thing they want is the perpendicular height, which they've marked in with a red H. So I'm just drawing the triangle which is where the H is part of the triangle. So I'm drawing this red dotted triangle, but I'm not drawing it in depth like they have. I'm just drawing it as a flat triangle. So I've got a right angle triangle, I've got H, I've got 26 for my hypotenuse, and this side down here, they've given us nothing, but we should be able to find it. If that side goes from here, the middle of this side, to the middle point of the shape, right, it's the same as this one in depth. So if we take that 20 across to here, that's 20. That's 20, that's 20. So this is half of 20. So that's going to be 10 that side there. All right, so we're going to put a 10 there in red pen, just so you can see we actually had to find that. All right, so it's basically I've done 20 divided by 2, or halved 20, that particular one there, to get that 10. Okay, so now we're going to use Pythagoras' theorem to find out what H is. So we have 26 squared equals H squared plus 10 squared. We'll move our plus 10 squared to the other side. So we have 26 squared minus 10 squared. And if you work that out on the calculator, you're going to get 576. We're now going to get rid of our square root, our squared by square rooting over here. Do the opposite. And that gives you exactly 24. So don't worry about the 2 decimal places if it's giving you a whole number. Just leave it. Okay, we might write the units on that as well, centimetres. All right, now we're going to part 2, the volume. So we can see it's a pyramid going to a point, so we're going to do V equals 1/3 AH. And remember, our base shape is a square, so we're putting S squared in for our area formula. So now we're ready to put our numbers in. So we've got 1/3 times, the side length of the square is 20, so we're going to have 20 squared times. Now the perpendicular height of the pyramid comes away from the square base and up to the point at right angles. So that's the H you just found. So we just found that was 24, so that's going in there. And now you work it out on your calculator, and it works out to be 3,200. and centimetres cubed on the end for volume. Don't do two decimal places if it works out to just be a whole number. Now in part 3 they're asking for capacity. That's when we're talking about changing it to a liquid measurement like litres, millilitres, kilolitres. So we're just going to take our answer here and change it into millilitres. Okay, so you need to know this yourself. How many centimetres cubed equals how many millilitres? So remember, a centimetre cubed is a little cube with 1 centimetre side lengths. Very small cube. How many millilitres fit into that? 1. So you need to know that 1 centimetre cubed equals 1 millilitre. 1 for 1. So if we have 3,200 centimetres cubed, and we have 3,200 millilitres. And that's the end of that question. So we're going to do another one like that in the next video and a few more examples.